This exchange project deals with ancient texts, and we have different collaborators who are humanities scholars as well as computer scientists from visualization and natural language processing, and so we are working closely, and this is a part of the work that we did over there that is about exploring ancient text with a user-directed concept search. So I will explain in the next slides what it is. The outline is first I tell the motivation, why was this important in the project and why it's important in the community. Then I will explain some of the technical details that how what we mean by concept search, what is the pipeline, what do we have different things as an editor, a concept search, and what's the viewer, and how do we manipulate with them. And then I will also like to show you some demonstration of the tool, and then I will discuss some of the results and findings that we were able to get from the tool, and then we will conclude the talk. So, yeah, the thing is that it's all about search, whether it's modern or it's ancient text. One of the goals of researchers or everyday people is that you want to search from the data. And even if there is a perfect search engine, like even as extensive as Google, if you do not have a good search query, you will end up having a bad set of results. That's always the case. So the garbage in, garbage out, or the better query in, so better results out is the theory, and this was also mentioned in a paper as mentioned here. So the most prominent method that is used for doing searching is keyword search, as we know of, starting from Google, everywhere. This is the most frequent method, and there are reasons for using this method. It's simple, and then, as I said, it's most popular. One can reformulate the query to get better results. So if you're not satisfied, you just change the query, you see the results. You are still not satisfied, you change it until the time you get to some better results. So that's the power of a keyword search. That it's just a textual environment. You just write 3-4 words and then you can get better results. That's why it's quite popular. And as I said, in research paradigms, even in digital humanities, we have certain like Persuas is one where you can search text. There are other for Latin text like V Latin text, and many other corpora from where you can have this keyword search with different possibilities. So coming to our project, we are also searching for ancient texts only, where ancient texts before Christ and at that time, Greek texts as well as Latin texts, both. So this is the interest of our humanities scholars. And the motivation of this project comes from terms like this. When a humanities scholar wants to investigate a concept like epilepsy from this ancient text, then he or she finds trouble in finding results, because that text can be represented in different ways. There is a famous term, morbus comitialis, disease of the assembly in English, as they told me. And so this is one term that is used for representing epilepsy in those ancient texts. But then when they only look through this word, then they get some not extensive result set. So the result set is precise, but it's very limited. So it doesn't encompass the whole concept of epilepsy. Then they try to truncate the search, that other forms could have been used by the user or by the author. But when they truncate the search, then it's quite obvious that they will get some results which are which match the query exactly, but then they are false positives. So the precision is affected here. Then there are alternate terms representing the same kind of concept, like morbus succor, that was used in some other times to represent epilepsy or epilepsia, maybe even later. And then there is another problem that some authors do not use these terms at all, which are representative terms. They use some descriptive terms or morphological terms. Some poets use some morphological terms that are, let's say, spuma, considere, etc. These are terms that can mean epilepsy, maybe 1% of the time, 2% of the time, but they are also in the text representing the same information. And another problem or another fact about ancient texts is that not only the vocabulary is not known about these, or is not, it is known, but because the vocabulary was quite limited, so it can have several meaning, and every humanities scholar can have different understanding of the same word or different variants of understanding because of different ideas, cultures and practices that he or she has in mind about that era. So, to study ancient text is not so trivial. So we need some close involvement of the humanities scholars in the process, that they can also contribute. So a simple search environment won't suffice. There are quite advanced techniques to do this that are developed over the last decades. Maybe in the last decade, there has been a lot of progress in the semantic search and stochastic or statistical search approaches. So semantic text approaches take advantage of the semantic meaning between different words. So they have a large thesaurus space or a large synonym base, like word sense disambiguation, where as the word says, that there are relationships between the different words, that which word makes sense with other words, and then there can be ontology-based searching approach. So these approaches take advantage of the semantic knowledge present in the text. Then there are also statistical approaches like topic models that take advantage of different statistic or stochastic approaches, stochastic relationship between the text overall and intertext. So then you can have different topic derived from these set of statistics. You can look into the literature about these techniques, but largely we can say that these techniques do not fit exactly or right into the domain of digital humanities as a whole, at least for the ancient text, because these techniques have a black box problem. And what do we mean by black box? Is that even keyword search has a black box problem. Everything, a computer scientist's job is to provide a black box to the different users so that they can input their data and something can be provided as an output. So, but the beauty of keyword search is that when you provide some input, you can reformulate your query again and again, so you can steer the search as you require. So, there isn't this black box present, but because of the steering, this is not a problem for a humanities scholar. But in case of this semantic or statistical search approaches, this black box is quite hidden from the user. So all these things like semantic stuff or statistical stuff is done by the computer, which makes these models, and then on based of these models you get some search results. There is possibility that the Humanities scholar can, if if he has learned these approaches, how they work, then can set the parameters how to manipulate these search results. But it's still quite limited because there is a lot of computer role to play, and you cannot really steer the search results like in case of keyword search. So our goal was to model something based like keyword search, where we can have this full word truncated alternate descriptive terms, where we can model all these kind of terms that I showed in case of epilepsy. And then the important factor is that we wanted to have the ability to steer the search process as desired by the user. And when you have this ability to steer the search, then iteratively improve the results as likewise in keyword search. So the solution was that we proposed was to provide a visual search environment where the user is provided the ability to model their idea of concept, for example epilepsy, and then to search the concept models that the user has defined and iteratively improve results. How do we do that? Is something like this, that we provide a concept model where again there is a black box of concept search, but then this concept model is used to show the results, and the user can change the concept model and the results will change accordingly. So it's something which is following the same principle of keyword search, and where one can get or hope to get better results like in case of keyword search. So this is, I'm going to explain the concept search pipeline now. So we have three main components in the concept pipeline, concept search pipeline: the concept editor, concept search, and the concept search viewer. First comes the concept editor, which is the editor to model the concepts. And we take our definition of model concept model from mind maps as well as concept maps. There are several definitions of mind maps and concept maps. What we chose was that mind map represents most of the time one concept. So like in case it's sort of a hierarchical relationship or a tree relationship, where in the middle there is this idea which we are focusing on, a topic which someone is focusing on, and everything you write about or through arrows and descriptions, it's pointing to that. In case of a concept map, you relate different concepts together, that how energy is related to electricity, how energy is related to lightning, and so on. So these are the inspiration of our concept model. So we have a hybrid of a concept model, a mind map and a concept map, where for one particular concept we follow the same approach of a mind map, that the middle one is the concept which we are wanting to search, so it behaves like a mind map. But when we try to look relationship between different two concepts, then it can behave something like a concept map. So this is the interface of the concept editor. I will also later show in the demonstration. This is some model concept by the Humanities scholar, which I will also show you later. So what is our concept model? It is a simple tree data structure. We choose it tree as it's quite easy for the humanities scholars to use it, to model it, and then we need to later lay out this or relay out this to show the results. Why we do this, I will tell you later. And so for these reasons, we chose it as this data structure. Then we have this blue box, the main concept. Then we have different, these rectangular things or boxes are the concepts, and these oval ones are the terms. And we have different relationships. The green ones define, if we can, if the colors are correctly represented, top two are green, dark green and light green. Similarly, light red color and red colors represent different kind of relationship. We are starting from very strong to not needed. And then we have different rules for that. The main concept can only have subconcepts and it cannot directly have terms. It is for the use of the need that we had. So we designed it like this. That main concept can only have subconcepts. Some subconcepts can have subconcepts of or terms. So these are some technical terms. And this is again the picture from the editor. I will explain later. And if you want to further look into this concept editor, you can refer to our paper in Digital Humanities 2015, the Digital Humanities Conference. In 2015 we explained this also over there, and it's there in the abstracts. One feature of concept editor is that for every term that I showed in the oval box, you can choose the word forms of each term. So whatever word form is required for that particular term. So let's say it shows 15 word forms for Quartana, so the user can choose whatever word forms he or she likes to choose for the particular concept based on grammar, like I only want nouns or verbs. This word goes only with nouns and similar things like so relations that make sense to the humanities scholar can be represented like this, and then these terms basically form the basis of the search alliance, like in keyword search. Then is the next thing, concept search, where all the word forms of all terms are searched, and this is a simple classical string lookup, and per word all the occurrences are located and grouped within these terms and counted within these term groups. And so I get simple non-negative integer matrix, which is, and we use this matrix to rank the result according to the concept hierarchy. Again, you can look into our paper that I refer in the next slides for more details on this thing. Then what we want to do is we have these concept nodes that I showed in the last slide, this one. So these are the concept nodes. So we want to fit in those search results within these concept nodes. Why do we want to do this? Because as I said, this is sort of a hierarchical relationship. So anything that comes closer to the root node, the main concept will be termed as more closer to the concept, and far away, it will be far away from the concept or closely related to the concept box in which it is represented. So that's so we assign the results to the concept nodes, and we show this result in the user concept hierarchy as I showed you just, so that the results are there, and we have these concept nodes, and we want to place these results into the concept nodes. Like in case of where we have, let's say, 6 results. So we did, for A, its present word forms are spuma, nervus, lumen, morbus, and venum. So it looks it up. The easiest strategy could be just that if the word form is present, just move it up for this, and again if it's present, move it up, and similarly moving up the hierarchy when everything is present, so the A ends up somewhere in the top hierarchy because it's represented everywhere in the concept hierarchy. Similarly goes for B, it's present in 2 subtrees and not in the third, so it is represented best, we see in the epilepsy labels after we calculated that it's more present in here. And similarly C is only the negative term, so we do not represent it. D, E and F are also calculated, so based on similar principles, so they are placed in somewhere in the hierarchy where they are best placed according to the concept nodes. And then there are different parameters that can be tweaked to for better node assignment of results. So how to that we can say that we do not want all the results to move up when everything is there. We say we want a threshold, or we want to use the dark or lighter shades that I showed you, the dark green or light green, or we want to have aggregation of different results that they aggregate and they are duplicated in different nodes. So there can be multiple criteria how the results can be moved from one node to another, whether they are just moved or they are duplicated, etc. And within a concept node, the results can be ranked according to their term variance or their word count, or the ratio of positive to negative words, titles, or their combination. So within a concept node, you can have different ranking. And the last thing is the concept search in the concept search pipeline is the viewer, where we show these results, and so when these things are the results are placed in the nodes, they are expanded. So something like when we place from here, when we place the results here, so there is overlapping because the nodes are now expanded, they contain the search results, and now we need some kind of algorithm. We have a bottom-up approach that solves and that tries to keep the topology same as this, and then the results are placed in this node. So that's how we do it. And for further details, we have a paper in as linked in the references, so you can look it up for further details on how this is done, and the rest of the things as I explained, the node placement, etc. This is the visualization that we created. This is the aggregated view, where these small boxes show information about the text messages obtained. So this is ranked the highest movement, and these are showing based on the sort criteria you chose how the results look like. Which results are more important, which are less important, which are placed due to the placement algorithm, and this is the aggregate view. Then we can also have a word summaries view, where when all the other concept nodes are shrink, and these are the tag pies, which are word summaries view that show how this particular passage is represented, or set of passages is represented in different, or their word distribution is represented in different subtrees of this particular concept. For further details about what a tag pie is, you can refer to this link. And then we also have a closed reading view, where the user, the scholar, can look into the text, particular text, can note down whether the term is, whether the result is relevant or not relevant, can put some notes down, and also can navigate with looking next sentences or previous sentences in the text. And then an important feature of the result viewer should be that the user can be able to export the result as well as to reuse those results. So, which is quite an important feature for a scholar that does not want to sit in one single session and then to expect the user to see all the results. So we can manipulate other, or we can save the results. So we can save different tables as I showed in the last, that the user can select whether a thing is relevant, not relevant, or interesting. So the user can then export different tables for the relevant results, for the irrelevant results, for the interesting results by selecting the particular button for the use. And then the user also has the option to save all things, including the session as well as all the tables. So it will save all things. So this is the interface that I will show you in a few minutes in the demo. Background about the humanities scholars in the project, that we had 6 humanities scholars in the project, but 2 were quite working on the project, or 2 humanities scholars were working in this project, in this particular case of concept search. They were extensively using this concept search environment. There was stark difference in the approach of both scholars. One was quite interested to look in the distance reading aspect. Was more interested to look in the how the terms are distributed in different parts of the concept model, and the relationship between those. So was more interested in the distant reading aspect. The other scholar was is more concerned by reading the passage. For her, the distant reading is not the first feature needed, but it definitely helps her. But she is more interested to use the close reading views, and so that was something which we were happy that we could get some different observations from both scholars. This is the example that I also wrote in the abstract. This is coming from this old text, which is bloodletting, how the doctors used to take blood, and this sanguis was blood, and these terms were there to represent the taking operation, how to take the blood, like mittere, emittere, titre, and so on. So the user, the scholar made this concept, and then we ran the search algorithm on it, and then we can see for each word how the terms are represented for each of the passage, and then there are several kind of observations by the scholar that I also mentioned in the abstract, that how the user found this. I can show you the demo now, which should make sense because so that's so the user can, for example, open already built concept model and try to add some terms to it. So my sanguis was created here, and then the user can have different word forms. It's still loading the word forms from the database. I can show you that from the older. So the user selected different word forms which were needed, or which the scholar thought were connected to this bloodletting, and also chose not to choose these some of the word forms because thought that they are probably nouns or so, and they do not relate to the concept. Like here also they are loaded, and the user can select which terms they want, and then the user can easily put these and then create relationships, and in the end save it and then export it for the next phase. So it's quite easy to use for the humanities scholars. It's not that difficult because we have not so many buttons there. It's just 3 different types of main concept, sub-concept terms, and then their relationship. And if you follow the rules, it's quite then trivial to make a concept. After the concept is made, then the user can select that concept which was made, and then can choose the searching criteria. For example, do not rank by the color variance, do not allow duplicate results. We can have different sorting criteria for a concept box, and then if the user wants to choose some previous saved concept result, then can choose that, and then can load the concept. It will take some seconds. I made a local copy of it. So now, as you can see, this is loaded, and the user can now see and navigate and see the all marked results. The user marked this as relevant, and then it's just a prototype where the user can do this. It's like interesting, not interesting, so the user can see and then write notes about something that this seems quite interesting, further investigation needed, etc. And then mark is that interesting, and then you can have the good thing about this is that you can export all the results in one click. Let's say when you do this, save all, so you have different results where the user can now so the user can let's say have all the tables exported and can see how the results are represented, and for further use, for further investigation and saving the table, this is quite important feature that the user can save the session and reuse these results. And the user can also click one of the boxes and can look at how the birds are represented in different tag pies, that how the distribution is there, and can navigate through all the results, and can also see this in close reading. So it's a distant reading as well as close reading view. So that's a short demo of what we have made. Next comes the steering of the search process that I was advocating in the beginning, that one can remodel a concept, which is quite needed thing, because the scholar is working on different hypotheses that what he or she thinks about that particular concept can be true or cannot hold true, but he or she has to investigate the hypothesis, and if the hypothesis is correct, then the results are verified. If the hypothesis fails to incorporate this scenario, then this is so that was the earlier concept that I showed, the concept of epilepsy. So this was our first version of epilepsy that we also showed in the Digital Humanities conference in 2015, which had a lot of assumptions from the user, from the scholar, that how the epilepsy is represented in the past, that how there were different terms, also in Greek, representing the concept, and then there are different symptoms that relate to epilepsy, like affected, which are the affected parts of the body, what happens when someone is epileptic, what are the signs of it, and they are not related with fever symptoms, as the red explains this. So it was something that the humanities scholar thought that how this particular concept should be written or should be visualized. And then after we made the concept search, we ran a search on it, and we got some results. And what was the scholar's point of view after seeing the results? She was not at all satisfied, and she started to observe why she was not satisfied, because what she thought important at places were actually destroying the search results. So there were a lot of morphological word forms like these human, oculus, nervous, that were sort of totally destroying the search results. They were there in the results, but the result base was getting a lot, and the accuracy was, or the precision was severely affected. And then also she noticed that these kind of venom or apparatus, these terms are there to represent epilepsy, but very, very rarely. So she wanted to omit, because otherwise she was getting a lot of results, and so she decided to reformulate the concept as after seeing the first search results. So like in case of keyword, we reformulate the query. So here she reformulated the same concept, and now what happened was that epilepsy symptoms was shrunk, and we had this only the related symptoms were there, and also the causes node, she didn't find it intriguing, so she removed it. And then again we got some search results where she again had some observation. She was still not satisfied with the results, and quite obvious, because the precision was still not so good. We had a lot of results coming from morbus, Morbus, Meyer, and Sucker were three terms that were here that had a lot of results in the main concept as well as epilepsy labels, and they were not related to the epilepsy concept in the end. But because they were there, so they were polluting the whole concept. So she was still not happy, and like in the causes box, she thought that the moral terms and political terms we can probably omit in the next version, because then we get a precise definition of, or she could get some precise results as she wanted, and that's what we did. So removed the red nodes as well as Morbus, Meyer, and Sucker, and then she was quite satisfied with the results that she got in this third case. But the problem was, or as you can see that from the second we were getting a lot many results. But in case of third, there were only 4 results that were related. They were all related to the concept epilepsy. So in the blue box we can say that the precision was 100%, but the set is too small, so the recall was affected badly in this case. So the term, when you have the small term base, the results are there. When they are precise term based, so the results will be there, but then the concept will not be that broad. So this is what we did not want. So it was an expanded keyword search. It was much more than a keyword search, because we are looking at thousands of word forms at the same time. So every term can have several of word forms, and all these will be searched. So it's still better than a keyword search in comparison, but still we wanted more. So we thought of getting something. After this, we thought that we needed something better strategy of modeling. So what we did was remodel the concept based on the set theory principle. That is, that these light greens mean that when these light green sub-concepts, when they occur together, only then they make sense for the epilepsy. This is what was her observation, that morbus Sucker or morbus Meyer are related to epilepsy. But if it's only morbus or Sucker or Meyer, then it does not make a lot of sense to the user. So for her, it was more important that these combinations are represented in the model. So like here, it only makes sense when we have the type and disease working together, and then this term makes sense for the concept epilepsy. So in this version 4, similarly, symptoms when representing only stoma or agere, they do not, or they rarely make sense for epilepsy. For her to make it sense, as she noted from her previous knowledge, that that the authors who defined epilepsy only defined when stoma and agere were together. So so we made it sure that only these combinations, when they occur together, only then they can move in the hierarchy, and only then they will be shown. Independent results will be still shown, but very far, so they do not destroy the main concept. So we searched through after making this version, and the user was really satisfied with the search results, but not entirely. The reason was that still the morbus Sucker and terms like this were making the results bad. The reason was that the database that we have, the backend we have, was to a limited time, and she figured out that the morbus Sucker was there in the text in the later times. But the authors of that time did not use morbus Sucker for epilepsy, maybe once, but not a lot. So this particular node of morbus Sucker and morbus Meyer was not needed for this backend. So she said that let's remove this, and then there were also some terms in the caducus that she didn't want, and she thought that they are not related really to the epilepsy, as she observed from the results. And when she omitted this was the final version we got for epilepsy. So we had 5 iterations, or the Humanities scholar had 5 iterations, and then the search results that she got were largely satisfying for her. And this was what she mentioned was that in this particular box, this pinkish color was interesting results for her. And this was the thing that invoked her most, that she was really interested in these results. Others were making her hypothesis, the green are making her hypothesis true, which maybe she knew, or because that was a known concept to her already, and she was making a hypothetical model based on our hypothesis or knowledge. So she verified all the green results that they are quite relevant, and the interesting ones she marked in this pinkish color, and she said that they are quite interesting. Why they are interesting? Because she figured out that stoma agere, which was what she thought was represented as epilepsy, she figured out that none of the authors, except the author she knew, used it as in epilepsy form. So what she figured out was some kind of phrase he used, that she saw that stoma agere was in later times used as from some author, I think it was Ennius, who used this in terms of to define a wild horse when talking about Spuma agere, and then there were other authors who used Spuma agere term, this combination of terms to define a brave man. So detection of phrase reuse was something that was quite interesting for her, and how her hypothesis that Spuma agere was a term to define epilepsy was proven wrong after multiple searches. So that is sort of the summary of the version 2 to 5. We omitted the results of version 5 because they were quite trash and we needed to reformulate the query. And this is a summary of approximate precision. Here you see that in the middle box where the epilepsy results are. So in the version 2 we get a total of 38 results. Out of them only 30% represent the relevant concepts. Here we have 4 concepts and all of them represent the concept epilepsy. Here we had 302 results and out of them only 40% represented version 4. And in version 5, 124 out of 174 represent the correct concept. So she was really interested after seeing this. This is a largely satisfying precision, that if you get 70% results that satisfy. And why do I call it approximate precision? Because for example, in this particular case or in this particular cases, the scholar wasn't able to go through all the 7,000 or 800 results, only a subset of results, and then we approximated that 20% of the results are representing the labels, maybe even less if she had gone through. So we reformulated, and in the later cases she could go through all the results. So that's the summary of the different versions. The findings that we had after this particular step was that we can now steer the results likewise in case of keyword search, which is quite an important factor, which the humanities scholar are happy about, that they can remodel their concept, and then if they are not satisfied, if their hypothesis proves wrong or if their hypothesis proves right, so they can further modify the concept, and then also they can, when they are looking for, they can find new terms that were that they didn't have in mind at that time, so they can add those terms, they can add different sub-concepts, and then so the remodeling of the concept iteratively can help the scholar to increase the recall. So the recall is an important thing that the user always wants to improve on while keeping the precision factor high. That was what we saw when we had the version 4 and version 5, where we kept the recall same, and we improved the precision factor. And as I said, that there is this phrase detection due to this combination of terms that we want to look in, and due to these phrases, or when two phrases from different concepts are combining, then the user can look into these terms and how the terms were used in different eras, in different genre, and so on. And these things are not particularly available in the dictionaries as observed by the scholar. So these are there in commentaries, but not in dictionaries. So this is something that was quite beneficial for her. And as I said, that the phrase reuse can be detected based on time, genre, author. So one can look at a semantic development of how a phrase is being developed over time using this tool. And finally, the scholars can verify or falsify their hypothesis, that how the defined concept can be remodeled, and then the string modeling can be iteratively done, and then the scholar can verify whether this was the correct knowledge, or in case of scuba upgrade or other terms, she was able to identify that her hypothesis was just based on one poetic one poet who used this term morphologically different, and the real meaning was different. That was it about the concept, how you iteratively make a concept. After this, there is another. This is one thing, that you make a concept, but what you do after making a concept, that you also want to further query on that particular concept when you are done with it. So that's something what we call as inter-concept search, that the user was not satisfied with the concept created for epilepsy, but for example, she wanted to further look into it. So these are the texts relating to epilepsy, but what medicines were given for the epilepsy persons. So she made a small concept of given, that these are the terms that were used in text when representing something given. So Turascio, Medere, Sibus, Utile, and some other terms. And she represented these terms and then looked for an intersection between these terms, that how these terms are represented. And finally, she got some terms which she marked as, so she got 32 results in the middle, where she was able to find 22 terms, 22 results that were matching her expectation, and some around 8 results or 9 results were not matching, because she said that the results are right, but they are used in some other morphological sense, in some other sense mostly related to Kabukus. And so she was not bothered about these results, but she said that this is a very nice feature where she can use the built concept and then look further into, let's say, what were the medicines given, and then another question could be that those epileptic patients were not welcomed by the society, so there was some terms like spitting or so. So in how many books or how many texts are these people hated or used hateful terms against these persons? So one can use this kind of thing to draw a visual query environment where you can query on a particular concept. So now I come to the conclusion. Before I come towards the conclusion, I again reiterate the limitations of our current system. First is that we had a really bad metadata, and we couldn't do anything about it. Time, genre, author, everything was mixed. And it was something beneficial in the end for the user, because she was able to detect this phrase reuse over time. If I had filtered it with a particular time or particular author, she wouldn't have been able to identify things. So it has its benefit, but then you have a large result set, which in most cases won't be beneficial. So having a filtering would be beneficial, but because of the bad metadata, we couldn't do anything about it. And the second limitation was that we can define only distance between words at sentence level. So what the scholars would have liked was you can define word distance level, that these terms are only related with at let's say word distance of 1 or 2, which makes sense, because if one word is there in the beginning of the sentence, the other is in the end. So as the scholar told me, that most of the time it does not make sense when talking about something specific like epilepsy or so. So it should be better if they are closely related, but we couldn't do anything because our backend did not support it. this is the limitation. And as we saw that we are from this particular modeling and then reusing that modeling, showing the results in that model, and then able to reformulate it, we get away from this working, or we get away from a big black box, and we can come closer to a keyword search environment where we can reformulate the query, and the user has a particular control over the whole process. So as you can see that in this case, the user derived the search. So in all the versions, what she thought we represented in the concept, and then she was able to represent what she thought, and not by particularly what the computer thought. The search system is able to search thousands of word forms at the same time and represent them, and represent them in a compact way. The word forms are considered and ranked according to the different criteria. So it's a step towards extracting more and accurate results of a concept. So the more terms that we can define for a particular concept, the more accurate results it can be. The keyword search has a problem that you can only look for one term at one time, and another term, and then you have to yourself combine the results. Here you can just model them and then have them aggregated in the main node. And iterative improvement, as I have said before, the phrase reuse can be detected, and then we can provide a visual query environment, as we saw in the last use case. And we believe that this is also applicable even for the modern languages, but we haven't tested, so it's just a hypothesis that this can be applicable to other domains, maybe to modern languages and newer system. And we may also use, when we are defining a model, it is debatable whether we want to give the user something like semantic help, or so that the user gets hints on this word has these synonyms. Do you want to also put all the synonyms together? This may be misleading, or this can be also helpful, because if the user sees 10 synonyms, may say put all them, and it's something debatable, but it can be applicable to other domains, and we can also expand the searching criteria, modeling criteria, and there is room for this as a future work. And these are the references to our papers, and then one of my colleague, Stefan Janicke, about the tag pies. You can look up if you want further information about this. And thanks for listening to the talk. Any questions, suggestions?